Good morning. Thank you for being here. Um, my name is Joan Llort. I come from the Barcelona Supercomputing Center here in Barcelona, but I'm also involved in SOLAS, that is one of the two organizations that is organizing this event, and you'll learn a bit more about SOLAS later. I will briefly introduce the event and why we're here, why I think that it's interesting that we explore the ERC interface. So there's a quote I found yesterday by this marine biologist from the beginning of the century that says, "Always the edge of the sea remains an elusive and indefinable boundary." And I think that's a beautiful way of introducing the matter that we'll discuss today. Because unlike the air-land interface, the air-sea boundary is flexible, is dynamic and permeable. Air and sea are two fluids with very different densities and chemical properties, but two fluids after all. That makes this interface extremely complex to study and is beautifully put by Rachel's quote, that is almost elusive and indefinable. So we, as researchers on the ERC interface, we're always trying to fight these difficulties. So here we are, two international organizations working against all odds to define and determine this boundary and all the relevant changes happening in them. Actually, some of the most relevant roles of the ocean in our climate start at this boundary. Without the heat and carbon exchange occurring at the microscopic turbulence scales, the ocean could not have absorbed 90% of the heat excess or 30% of the emitted CO2. Photosynthesis would not be impossible either. And then how is it possible that it took so long to connect both communities? Well, atmospheric and oceanic communities evolved in parallel for a long time, trying to explain different phenomena. But the more we advance, the more we realize how critical it is to work together and generate a new integrative discipline that brings Sverdrup and Hadley together, as Ekman did. That is even more true now, with the pressing urgency to strategically decide which air-sea mechanisms need to be represented at which degree of complexity in Earth system models that can inform stakeholders. The Ocean Decade provides the perfect context to push forward our efforts to understand air-sea exchange and improve its representation in models. An excellent example of this momentum is the good health of the two communities leading this event, OASIS and SOLAS, which have joined efforts to organize and invite you to participate in the forum we're opening right now. So I'm very excited to see many more joint events coming in the near future, and we hope that this one will set the foundations for a common strategy that will contribute to the decade challenges. So I would like now to welcome the panelists that we have here. So we'll have an introduction. Each of them, they will introduce themselves, and we can start with Nick Rom. So please, Nick.
Thank you, John. And will I be going straight into the slides?
Yes.
Okay.
Here we are.
Thank you. Okay, hi everybody. Welcome, and it's an honor to be here with all of you in Barcelona in this room full of many, many experts. Thank you for attending. My name is Nick Rome. I'm with UCAR's Center for Ocean Leadership. We're based out of Boulder, Colorado in the US. I'm going to give you an overview of OASIS, and then I was asked to provide a commentary on how we can strengthen and expand our network. So first, just a little bit of background on OASIS. It's the Ocean Air Sea Interactions Strategy. 5 years ago, thousands of oceanographers convened for the OceanObs 19 conference in Honolulu, Hawaii. And this was to chart out some new advancements in our field. And there were over 140 papers, strategic papers that were published for this conference. And so the OASIS community sat down, leadership within OASIS sat down and did some analysis on these 140 papers and found that a third of them touched air-sea interactions in some way. And so this led to a coalescing of all of the interested parties, and then that grew into this community now known as OASIS. So one of the first things we did was then take OASIS and establish it as a UN Ocean Decade program, and that's why we're here today. And so in the most succinct terms, what OASIS is trying to accomplish is represented here on this slide, It's expanding our network of in-situ observations, optimizing observations from satellites, and improving Earth systems models. Next slide. And so this slide shows how we harmonize those community recommendations from those papers that I mentioned from OceanObs 19. And then we also took, if you remember, there were these decade laboratories that were held in the first and second year once the decade was launched. We took that information and distilled it into the three objectives that I mentioned before: in situ obs, satellite obs, and models. And we dubbed those our grand ideas. And then, so the purpose of this slide right here, this triangle thing, all of those little tiny gray words that you can't see, those were the authors and the year of the publications that we referenced, and we mapped them to each of the grand ideas. And so really the purpose of that is to show that the decisions of how we've structured OASIS isn't being made in a vacuum. It's based on, the voices and things we've heard from thousands of the co-authors on these papers. And then ultimately at the top, in addition to the three big ideas, this kind of gets at the societal benefits of why we're trying to do this. And that is by quantifying ocean atmosphere fluxes, OASIS can enable the improvement of forecasts, weather, and ecosystems. And this also includes monitoring the uptake of CO2, which meets several global policy goals, many of which are outlined here at the decade this week, the Paris Agreement, and there's other societal goals and business initiatives. Last slide. And then so this is what I was asked to talk about from my own personal perspective. So how do we strengthen, and I think this is relevant not only to OASIS, but I think it's going to be impactful for everyone in the room, any decade program that you might be associated with. I think for OASIS specifically, our two biggest immediate challenges are improving our governance and recruiting new leadership, and that's this lower left box, these boxes here. We have great engagement already, but it's been 5 years, like I said, since OASIS was created, and we have dedicated experts who are doing all of the heavy lifting, and it's time that we need some fresh perspectives. We need new co-chair leadership on the steering committee. We need new leads of all of the subgroups, and we want to recruit as many early career scientists as we can to get engaged, because they will be the future of this network. And then I think if we really want to strengthen and expand our network, what I was asked to talk about, we have to be thinking externally, not just internally, on how do we engage partners both for advocating for OASIS, but also for the resources that we need, because none of our objectives will be accomplished without funding, obviously. So here's a step-by-step list on my left side of that slide on how to do it. And if you read this, you're probably thinking, did Nick just type that into ChatGPT and come up with the list? And the answer is yes. I apologize for that. But I think it revealed some very interesting, important next steps. I put an asterisk next to the first three, and I think that those three, identifying key partners, utilizing multi-channel communication, and engaging advocates and champions, these are areas where the UN Decade coordination mechanisms can really step up and play a role in helping us. It's who is not at the table that should be. What are those messages that we need to be communicating, and where, through what channels? And how can we find powerful voices that will help us advocate? And then the rest of the steps there fall on to us, OASIS, and that is mobilizing grassroots support. And by that, I mean our community. It's leveraging the data and evidence, applying the air-sea flux research for decision makers, and then building strategic partners. This includes government, industry, philanthropic institutions. And then finally, engaging in that direct advocacy, because we need to be arguing for why this program should be sustained so that after 2030, it will continue. So I'm happy to dig into these more in our discussion today, but I'd like to stop there and pass the microphone to my distinguished colleague, Lily, over here.
Thank you, Nick.
Thank you.
And hi, everyone. Here is Lily. and welcome to the OASIS SOLAS satellite event. I'm been working with SOLAS since 2017, and I'm the executive director of SOLAS. And since my colleague, my distinct mentioned the history of OASIS, I think as a co-convener of this event, SOLAS should not be left behind. So, all right. Then the story started like 3 billion years ago when the early ocean appeared. Sorry, we don't need to go that far. But back to the year of 2000, two groups of scientists, one from ocean community and the other one from atmospheric science community, they gathered in a small town, which is called Damp. It's a small town located 60 kilometers from Kiel. That's where a very well-known oceanographer research institute, GIOMA, is located. And I mean, those two groups of people gathered in Damp to discuss how the ocean scientists and atmospheric scientists could work together. So that's the first SOLAS Open Science Conference. And the people who attend that conference, they drafted the very first SOLAS science plan. And that science plan was approved by our four sponsors, which is IGBP, that's the former body of Future Earth, then ICACGP, which is international organization on atmospheric chemistry and global pollution, air pollution, and then SCORE, and WCRP. And that science plan was officially approved by these four sponsors officially in 2004. And after that is a story of success of 2 decades of SOLAS. And now SOLAS has a global network, and which consists of over 1,200 co-members. And we currently have 90 scientific steering committee members from 16 countries who provide scientific guidance to the management and the running of the whole program. And we have 2 international program offices. One is where I'm based at, is hosted by the State Key Laboratory of Marine Environmental Science in China. And the other one is hosted by the University of Galway in Ireland. And the 2 offices work together to manage the SOLAS program on a daily basis. And we recently launched an early career scientist committee, which consists 14 members from 10 countries. And they work closely with the SOLAS Scientific Steering Committee and the international program offices, and to champion the early career scientist activities in the SOLAS community. And in addition to that, SOLAS has 33 national and regional research networks across the globe. And they really, they kind of self-maintained and self-organized, but they provide annual reports to the SOLAS to make implementation strategy of annual SOLAS activities. And we also recently launched a regional panel in Southeast Asia, and similar efforts is still underway for other regions as well. For example, South America, Latin America, as well as in Africa. Yeah, that's the global networks. And SOLAS has been putting a lot of efforts in capacity building. So far, we have been organized 9 summer schools, which trained around 600 early career scientists. Those scientists are truly air-sea interaction scientists. And we are very proud to say the current co-chair of SOLAS and the OASIS, Krista Marindino, she is the attendance of the first SOLAS summer school in 2003. We're very proud of that. And so far, we have been organized 9 SOLAS Open Science Conferences, which welcomed 1,700 participants, and we organized over 100 thematic workshops within the SOLAS domain. And we also released e-bulletins, newsletters, annual reports, event reports to communicate the scientific progress within the SOLAS domain. Yeah, and we have over 40 endorsed and research projects, at regional and international, as well as national level, as well as 4 endorsed time series stations across the globe. Next slide, please. Yeah, currently all the SOLAS missions are organized around the second decadal science plan, and which consists of 5 core themes, which are greenhouse gases and ocean, including ocean acidification. And the second one is air-sea interface and the fluxes of mass energy. And the third one is about atmospheric deposition and its impact on the ocean. And then what's the connections between aerosols, clouds, and the marine ecosystems, and then how the marine biogeochemical process affect the atmospheric chemistry. And we also have some focuses on some regions, sensitive regions with high priorities like Indian Ocean, polar oceans, and coastal upwelling zones. And SOLAS is also investigating the environmental efficacy and impacts of climate intervention, and that team is quite active recently. The of that team, including they coordinate fundings to support SOLAS marine CDR postdoc programs, and then they develop standardizations for ocean alkalinity enhancement microcosm experiments, and they are also establishing SOLAS global SOLAS regional nodes to standardize the MCDR initiatives with a focus on reporting, with a focus on monitoring, reporting, and verification. And we also have a cross-cutting theme on solar science and society, and a major topic under that theme is shrimp plumes. What's the impacts of shrimp plumes to the ocean, especially the biogeochemical cycles? Next slide, please. Yeah, as I said, SOLAS was officially launched in 2004 with the first science plan, and now we're under the implementation of the second decadal science plan. And then what's next? Actually, we have been doing a lot of effort within SOLAS, and then also outside SOLAS, we invite sponsors and partners to frame the third decade of SOLAS. And I think we will talk a little bit about it later. Yeah. Thanks.
Thank you, Nick. Thank you, Lily. With that, we'll now follow the presentations of the other panelists. With more personal presentations about their expertise. And so please, Lucia.
Yeah, hi, welcome everyone. Thanks for being here. My name is Lucia Gutierrez Loza. I am currently a postdoc at NORS, and Norwegian Research Center, and affiliated to the Bjerknes Center for Climate Research. My work has been focused on air-sea gas exchange using mostly eddy-covariance measurements. And more recently, during my postdoc, I've been working with marine biogeochemistry, focusing on the polar regions. But I guess the reason why I'm here today in this panel, and thanks for the invitation, is because I've also been part of OASIS for a few months now. And I've been participating as an early career ocean professional and co-lead of the recommended practices theme team. And yeah, so the idea of this theme team is to identify, create, and promote recommended practices to build a sustained and integrated suite of platforms and networks for a better global observing system. And as part of these activities during the last few months, we've been organizing helping with the organization of a few events. One was last month, or no, in February, we had our OASIS face-to-face meeting. And then also last year, at the end of last year, we participated with a couple of sessions in the Ocean Best Practices System workshop, where we talk about recommended practices. But one session was particularly about radiation and recommended practices. And there is a paper coming out from Laura Rihimaki and et al. And then the other session was about this general discussion about the status of recommended practices for air-sea interactions observations. And there is a commentary paper on this in preparation. So stay tuned. And thanks for being here again, and thanks for the invitation.
Thank you, Lucia. now it's Martí. Sorry, it's not the right. Let's go to Martí because the next slide, and then we'll go to Shannon. Sorry. Yeah.
Right. Well, hello everyone, and thanks for having me today. As Juan said, I am Martí Galí, a researcher at the Marine Science Institute, the ICM in Barcelona. And well, as you can see here, my research interests are in the interactions between plankton and climate through both the carbon and the sulfur cycles. But here today I'm also representing a SCORE working group, which is called DMS Pro, which I'm going to talk about now. So, as I said, my interests are in the study of the sulfur cycle, and and through my career I have studied this through both in-situ studies and also Earth observation from autonomous platforms like satellites, and also through the numerical modeling in collaboration with atmospheric researchers. And something I wanted to say about the sulfur cycle is that this is one, so the dimethyl sulfide, a gas made by plankton which influences climate, is a topic that inherently connects the oceanic and atmospheric communities. And in fact, the study of these sulfur compounds in the ocean played a central role in the early steps in the establishment of SOLAS like 20 years ago. And so why is that? So as you see in this scheme that I put here, plankton ecosystems influence the cycling of many elements, including sulfur, and they produce in particular sulfur compounds in great amount. And part of these compounds are recycled by the food webs to produce volatile compounds that contain sulfur. And these volatiles, dimethyl sulfide, foremost, but also other compounds, they are emitted to the atmosphere where they will form aerosol particles. They will influence the scattering of sunlight by aerosols, and also they will influence the formation, the properties of clouds, so the albedo, the reflectance of the Earth. So, as you can see, this topic is inherently connecting both communities, although it is not as well known as, for example, carbon dioxide. And a particular interest of this cycle is that these compounds basically cool the Earth rather than heating it as greenhouse gases do. So, what is the DMS Pro SCORE working group? This is a group that was established 1 year ago only, and that together with a researcher in Argentina, Daniela Del Valle, I am co-chairing. And the goal of this working group is to produce a number of resources for the community to re-energize the study of the sulfur cycle in the ocean. And this includes initiatives like the creation of a database of the transformation rates of these sulfur compounds in the ocean, to produce also standard operating procedures and documents, which we will post eventually in the best practices repository. So harmonizing the existing methods for the measurement of the cycling rates of these compounds. And we are also going to produce some synthesis papers touching on different aspects like the database, measurement protocols, and modeling recommendations, for example. And the overarching goal of this group is to, as I said, create a global community of practice to re-energize this field of study, and to create resources and train a new community of researchers in the use of these resources. So it's our modest contribution to wider objectives of SOLAS, for example. And that's it.
Thank you, Martí. So now we'll end presentations with Shanling, please.
Yes. Good morning, everyone. I'm Shanling Chen from the Second Institute of Oceanography in China. The Second Institute of Oceanography actually belongs to the Ministry of Natural Resources of China, and I'm also I'm a young scholar at SIO, and my research interest mainly focuses on the air CO2 flux, and that's why I'm a member of the OASIS, and we are trying to right now we are trying to figure out a unified approach, to unify the in situ measurements with the satellite measurement together, for the CO2 flux observations. And as you can see, we are focusing on the air CO2 flux from the satellite. You can see the left panel is air CO2 trend. We all know that the air CO2 is increasing steadily in the past 50 years at least. And in the middle is a panel about the surface PCO2 measurements from the ocean. Even after 50 years, we still have lots of data gaps in the ocean. How can we figure that? If we only depend on the in situ measurement, we can never, work it out. So, but the satellite remote sensing has lots of advantage, especially from the spatial and temporal coverage. So we are trying to figure out how to combine, the advantage of the in situ and the satellite data together to develop a unified platform for the air CO2 flux observations. And here is an example that our lab has established. It's called the Sat CO2 platform. It's an online platform you can also access from the phone, from the desktop, and also from the website. This platform is not just focusing on the air CO2 flux. We also integrate lots of satellite data onto this platform. It's free. You can just register and log in to check the data, to browse the data, and to do interactive visualization and to do some analysis from that platform. And also, it's open to data collection. If you have any data want to share with the community, we are also happy to have that. Please just let us know. And as I oceanographer working on the air CO2 flux from the satellite. If you are interested, please just reach out. Okay, thank you.
Thank you. Thank you very much to all. So with that, we'll now start with the discussion. I first have 3 questions I'd like you to ask to all of you, and then we'll maybe target some other questions and also open questions to the public. The first one, maybe the most important one, is why do we need a unified strategy? So why we're here? Why are we trying to do that? Why do you think we need a unified strategy for air-sea research? So I don't know if somebody would like to start with the most difficult one. I think a way of framing this, we don't need to explain it to ourselves, is how we explain this to stakeholders, to private sector that is also in the conference, how we convince them that we need this unified, right, connecting with the OASIS challenges and SOLAS challenges to find funding sources, and how to explain these necessities.
Yeah, I mean, I can start and we can go down the line here, and I think we can go to the next slide as well.
Yes, sure.
Here, yeah. So why do we need a unified strategy for air-sea observations? I think Xualing's presentation kind of highlighted the importance of why we need air-sea flux research there. You look at the CO2 time series and it's not going down. And we're seeing those impacts, they're evident, and governments want us to use our resources efficiently and wisely. And so we need to understand what's happening at the boundary layer between the ocean and the atmosphere. And this community, I would say, more than almost any community, I think, based on my experience in working at a very high level with the ocean obs community, is the one that is the most directly plugged in to the climate and weather systems. And that's what I think resonates the most with the public. So if we're trying to distill why we're doing this and making the case for why we need research, we need a unified strategy. We need to have a common message that we can use to advocate for why we need additional resources to better understand it. And it's a no-brainer. It's, we need to understand how these systems work. There's no political agenda here. But the only way we're going to do that is if we come together as a community. So I think that's why we need a unified strategy.
Thank you, Nick.
Yeah.
Really?
Yeah, I mean, as said, SOLAS has been studying the physical and the biogeochemical between ocean and atmosphere, and as well as studying how the air-sea coupled system affects and is affected by climate and global change. We have been doing that for 20 years. But, I mean, this topic is more important than ever because of the continuous rise in greenhouse gas emissions, we all know, which has led to an accelerating increase in global ocean heat content, which result in like the melting of sea ice, the sea level rise, hypoxia, ocean acidification, etc. I mean, all these things, they further undermine the climate change, climate regulation capability of the air-sea coupled system. I mean, that's why we need to study it. But we all know it takes a lot of effort. It takes global efforts. And then we need we need observations, we need process studies, we need model development, and we need multidisciplinary studies that involve social sciences. I mean, all this needs to be accomplished by the work of researchers, research institutions, and scientific organizations across the globe. And I think that's why we need a unified strategy, I mean, to ensure the best use of the human, financial, and facility resources that we have to tackle the problems and then to achieve our sustainable development goals.
Thank you very much. Lucia.
Yes, I guess the air-sea interactions or the air-sea region is where most of life, including ourselves, the life on Earth, including the human life, it's living or it's affected directly by what happens between the ocean and the atmosphere. And there are so many processes, and it's so complex and so many interactions and feedbacks that there is no way to address and assess what's going on at the air-sea interaction only by looking at one perspective. I think we need to look at it as from a system as a whole perspective. Otherwise, there is no way we can improve the prediction of weather, climate, ocean, and of course, then to move forward a better warning systems, for example, prevent or predict extreme weather events, droughts, floods, etc., that are directly linked to the life we have now. So I think we really need a unified and coordinated that strategy that targets a multifunctional and multidisciplinary approach.
Okay. I think, I think everyone have a sense, the air-sea research is quite big, right? It covers lots of disciplines, the physical, the biogeochemical, lots of process going on at the air-sea interface. So each of us may focus on a different perspective, but for me, I focus on the CO2 flux. But for CO2 flux, there are lots of approaches to study, to study on it. Like the in-situ measurements, we can go to the sea to take a shape to do the measurements. We can also to stay at the office, just let the sunlight do it. So, but for different researchers, if they just focus on their own approach without communication, without a unified strategy, how can we figure out, how can we work it out? I think we won't make that much progress, at least from my perspective. So we really need to develop a unified strategy, whatever for the air-sea water exchange or the air-sea gas exchange, not just the CO2, and also the heat flux. So for everything, we need to develop a unified strategy. That's a key point, I think. Right. Thank you.
Thank you. Marty?
So I agree with all the panelists that it's very important to have an integrated strategy for observations and modeling. And from the point of view of the reactive gases that are emitted by the oceans or that are exchanged across the air-sea interface, this is particularly important because these gases are super reactive in the atmosphere. So once they are emitted, or they will have a lifetime or 1, 2, a few days in the atmosphere. So their effects are local. This means we need to know when and where these emissions are happening. And this is different from the case, for example, of CO2, no, that the greenhouse gas you are hearing about all the time, because CO2 is well mixed in the atmosphere. This is not the case for reactive compounds. And we need to talk to atmospheric chemists, for example, to know what are the most sensitive regions in the atmosphere to these natural emissions, to, for example, target our observation efforts in those areas. Because currently, if you look at the available observations of the sea surface concentrations or emissions, underlying processes in the ocean of these reactive volatile compounds, there is a mismatch between the regions that are most observed and the regions that are most sensitive to the climatic effects of these gases, for example. And the most obvious case is the Southern Ocean, which is a region where the natural emissions are super important, but which is very difficult to sample like comprehensively and in a sustained way over time and space, right? So this is just one further example.
Perfect. Thank you very much. Thank you for such a complimentary answers. It's not easy, so thank you, Joel. So a second question I would like you to ask is, and it's kind of a follow-up, kind of combines that we need this strategy, how we do it. So what are the key areas of priorities for the next 3-5 years? So for what is left of the decade? How can we address this strategy? What do you think?
Okay, I'll start. Same order. All right.
Please.
So I think the key areas for the next 3 to 5 years, there are so many, right? It's hard to really narrow it down, and I'll just give it from my biased perspective. I'm also, I should mention, I'm trained as a social scientist. So that's kind of where my perspectives come from, having studied political systems and how they're connected. But I guess in terms of, so I feel like we have a strategy, like we have OASIS. We've written the strategy, SOLAS has the science plan, and so I think the key priority for the next 3 to 5 years needs to be getting buy-in from the community. We have, and it's, I think it's low-hanging fruit, but we need to be looking across the various different groups and communities that share our interests and making sure that they're plugged into the work that we're doing, or at least, at the very least, bought into the work that we're doing, so that we can continue to, mobilize and grow our partnerships. But I would say, like, one area that I think that's really not being discussed that we need to be thinking about too is the workforce development, because I think it's obvious to us, we're preaching to the choir here at the UN Ocean Decade Conference that climate change is important, but I think that you're seeing less and less of the public prioritizing that as one of their topics of interest of what they're voting on, and I think it's our community who can really make that case, make it interesting, and come up with the ways to make it attractive for young talent to come in and work on air-sea flux, and not go to the tech companies and come work for our research institutions and keep growing this important body of research that we're doing. So,
Very good point. Yeah, thank you, Nick.
Yeah. Priorities, key priorities. I mean, that's an easy question for me because we're working on the third science plan. So it's not my answer. It's kind of a collective response from the whole SOLAS community as well as members from, who are outside the SOLAS community. And so we think the fundamental discovery science should still be a important component of the next decade within the SOLAS domain. We should address the questions, for example, like how air-sea interaction processes can they enhance or they interact with or respond to extreme events. and then how this interaction process, they regulate the trajectory and the future of Earth systems. And then in addition to the fundamental discovery science, we should give equal attention to the solution-oriented sciences, as well as capacity building. And there should be both like analysis of fundamental research data, which contribute to the informed solutions, as well as identifications of knowledge gaps to properly evaluate the solutions that is being considered. And then during the past, as I said, SOLAS has been putting a lot of efforts in capacity building. And then in the next decade, we will elevate that effort to a central priority as well. And there should be more engagement and opportunities for early career researchers. And we will establish new regional research networks. And we should further engage the Global South. And there should be enhanced resource availability mobilization. And there should be, we are also planning to organize like shared data and modeling expertise. Yeah, and then in addition to that, I think social sciences should be embedded in all the three priorities or directions. I think Nick would love that.
Thank you very much.
Yeah, I hate going after you guys. You got everything. No, yeah, I think I will sound like a broken record, but yeah, I think one of the key things is to develop a community of practice and really focus on the knowledge gaps on how we can work together to build a more interoperable system where we can look at the RC interactions from a broader perspective, not from our individual expertise. And this goes all the way from research to capacity building to data sharing to yeah, software development, everything. So we need to look into that from a broader perspective. And yeah, of course, the workforce development is particularly relevant for me, but I think there will be another question afterwards, so I won't go into that.
Spoiler.
Spoiler alert.
Okay. I think there are lots of key areas. One thing coming into my mind is the data. You know, data is always the most important thing. We need the data with very high accuracy to support our analysis of the RC interactions. You know, there are lots of processes going on under climate change, and the RC interface has the most direct impact from the climate change. We need lots of data to support our analysis. That's one thing. And also the other thing is we need to, from the science perspective, we need to figure out, you know, how the climate change is driving the RC interactions. You know, the global warming, the surface is also warming, right? The ocean surface is warming. One serious consequence of that is the thermocline is getting shallower. The ocean stratification, you know, is getting stronger. So with that, it definitely will affect, you know, the RC flux of the gases and also of the heat. So how that will change, you know, and the climate change. So I think that's the two things coming into my mind. Yes.
Thank you.
Great. So I won't insist on the importance of observations because I think they already convinced you, and I agree fully with my colleagues. And what I wanted to highlight is that we need to study the connection between observations and biogeochemical models. And I'm going to explain why, because there is currently huge knowledge gaps in the understanding of processes that drive the exchange of matter, energy through the RC interface. And this propagates to the models, the numerical models we are using to make projections of climate change scenarios. and to understand the current climate and the past climate, right? So we know from, for example, the last IPCC report and the last model intercomparison project, CMIP6, that models we're using currently, they lack lots of feedbacks between ocean and atmosphere through a huge amount of processes. So they just include a tiny proportion of the feedbacks between ocean and atmosphere. And we need to include them because we know that when we add more processes, we, for example, modify the baseline, historical, and present, to which, against which we are comparing the projections, for example, and against which we are assessing current estimates of the global climate system and energy fluxes and the energy balance of the Earth. So this must evolve much faster because it's frustrating to see that IPCC report after IPCC report, some uncertainties persist, for example, in things like the amount of light reflected by clouds, which affects like the CO2 sensitivity of models and other things, other processes. And for example, this also has practical consequences for things as important as the climate intervention techniques that are being proposed recently, like the carbon dioxide removal or the cloud seeding, for example, which consists of like sending aerosol particles to the atmosphere, which will make clouds brighter, so scatter sunlight. To evaluate this, we need to run model experiments first before we cause like unwanted consequences in our planet. But to be sure about these model predictions, we need to understand the mechanisms, and we don't understand many of the mechanisms right now. So that's why we need to communicate much faster.
Thank you very much. Really great points. So now a bit more targeted, as Lucia suggested, for the ECOPs in particular. Here we have a couple of ECOPs. I'm sorry, Marty. I think you're not an ECOP. No, I mean, you're not an ECOP anymore, right? I'm a late ECOP, but yeah. But Xuanling and Lucia can contribute on that. But the question is open to all of you, of course. What do you think are the ECOP challenges and opportunities in this area? I think that Nick and some of you already pointed to some of the challenges. For instance, the private sector is, for the case of marine CDRs, I'm seeing job offers with salaries that are astronomical, but I would never dream as being an oceanographer to have these salaries. So that's a huge challenge, how we attract people without these salaries, of course. But what do you think are also the opportunities we have in the current state?
Okay. Yes. So I think one of the major challenges that I see right now, at least from my personal perspective, is, but I guess this applies not only to OASIS interactions, but in general for ECOPs in research, is that it's very hard to swim in a multidisciplinary world. Like we've been now getting broader and broader, and I think that's particularly the case for OASIS interactions, where we have, as Xuanling mentioned before, we have physics, we have biochemistry, we have biology, and then we need to look into the past, into the present, into the future, observations, models, etc. So it becomes very, very multidisciplinary, and it's sometimes very hard to find where your expertise fits into this bigger context. And that doesn't mean that it's not relevant, but it's sometimes hard to swim in this ocean of multidisciplinarity. But I think, and this is one of the opportunities that I see, is that more and more there are networks that we can use. As Lily was saying, now there is this early career committee for SOLAS. We have also, we are very welcome in OASIS, but not only in this context. There are many early career networks that we can use and that are where we can feel welcome and we can feel oriented and where to move on and how to use our expertise.
I totally agree with Lucia. I'm an ECOP. People always say that the future belongs to ECOP, but where is the future? I can't see it. I think maybe it's not far away in the future, but right now we are still facing lots of challenges, and at least for me, I think the most big challenge is that as a young scientist, after you graduate from your PhD, you got your expertise. I know I worked on the LC CO2 flux, but the most big challenge is that how can you figure out the specific scientific question, the critical question you need to work on, to promote the research you focused on, right? I think that's one thing, the big thing we are facing right now. And also the other thing is the funding. As ECOP, it's very hard, to get fundings. But right now, I think we still need to be optimistic. There's lots of opportunities waiting for us. Maybe not just from the national level, and also the UN decade is a very, I think it's a very positive sign for the ECOP. There's ECOP communities for every perspective, every research perspective, I think. It covers the LC interactions, the physical, the biochemical. You can always find a spot. I think for the fundings, I care a lot about funding. And the fundings, I think you have to figure out a critical scientific question. Right now the bigger community care about to promote our science. And if you can figure out that, I think you got lots of opportunity for that. Yes, thank you.
Thank you. Thank you very much. Is there anything else you'd like to add? Okay, that's great. Thank you very much. I would like to open, perhaps lots of questions that we can keep discussing, but we'd like to open the opportunity to put questions to the audience if anybody in the room would like to contribute. We also have some questions already in the registration form, so is there anybody in the room that would like to put a question? Christina, please.
Hi, thank you very much. Thank you, Joan, for introducing me. I'm Cristina. I'm from the Marine Science Institute here in Barcelona, in SEM, like Martí. I would like to thank you for the interesting discussion you had. And me as an organizer, I'm a remote sensing oceanographer. Let's put it like that way. And as an organizer of another satellite event, we were kind of discussing the ocean monitoring in general, more than the air-sea fluxes. I am really interested to see your point of view. I mean, I do agree that we need a unified strategy, but maybe we would need also a unified funding. I don't know if from SOLAS or the OASIS initiative, are you communicating somehow with the GCOs or GOs to the global, I mean, in this big umbrella of ONU? I don't know, I'm completely naive. I don't know if this is already happening, but I think, I mean, as a ECOP or maybe late ECOP, like Joan said, funding is always a problem. I think, at least from the European perspective, we enroll in these ambitious research projects, but I have the impression, that's a personal reflection. I have the impression that we do a lot of interesting work in science and research, but somehow we need to raise our impact to really have an impact on the stakeholders and the policymakers. That's I don't know, what are your impressions on that?
Would you like to add something?
Yeah, maybe. May I?
Yes, please. Yeah.
Yeah, I mean, in terms of the funding, I fully agree with Shanling. I mean, national funding agencies is not the only opportunity. I mean, there are also regional and international organizations that you could go for. Like, I mean, we have a very good example that John and his colleagues get from the Future Earth ESA joint program to support their work. And SOLAS also had some successful stories to get ESA supported research programs. Yeah, that's the opportunities that you could explore. And then in terms of the impacts of the research, I think, the impacts of single one researchers is limited, right? But when we all come together, then the impact is amplified. Yeah, that's what I want to say.
Thank you. Anybody else? Yes.
Thank you for the question. I think I said earlier that we have a unified strategy. What we don't have is a unified funding strategy. and I think I really appreciate the question, because I think that is, I think it's hard to do given how expansive our networks are between SOLAS and OASIS, and I think that there's different funding mechanisms at every different global region, and you have to approach it on a sort of a case-by-case basis. But I think that's the responsibility of us as the organizers of these groups, and those that are involved in it. I think there's a responsibility. If you're a member of OASIS, when you sign on to come contribute to our body of work, one of your responsibilities should be going back to wherever your funding is coming from. You should be going back to those agencies and making the case about why they need to increase those levels of funding. I think that there's also, OASIS we had our first in-person meeting since OASIS was created at Ocean Sciences a few months ago. And it was incredible to see everyone come together, and it was a great cross-section of the ARC community. But there were some key voices that were missing, and there's other sources of I think we have to look at governments first, unfortunately, and international organizations for funding, because a lot of this research is intrinsic. And then from there, we need to be thinking about ways to build that business case about how it creates value for philanthropic organizations and private industry to come in. And we might be talking about that a little bit later as well.
Yeah. Great, thank you. You would like to add something?
No.
Yeah, there's another question. Yes, please.
Hi, it's Anya Wade. I'm the co-chair of the Global Ocean Observing System and CEO of Ocean Frontier Institute in Canada. What a wonderful discussion, so thank you for that this morning. Perhaps a small audience is made up for by our engagement and enthusiasm, so I really appreciate your discussion today. This is a really core issue. I heard, I think it was Sean Ling, it might have been someone else say, we are hopeful. And any entrepreneur will tell you hope is not a strategy. So I'm kind of going back to what Nick was saying, which is we have to think bigger about how to fund these kinds of initiatives. And yes, we start with governments, but we do have to engage with the private sector. And we have to engage with the public and with our policymakers. That's something that we do at Ocean Frontier Institute a lot, and so we're trying to support the global system that way. And also, Goose is doing its best through the Ocean Observation Co-Design Program to really have a strong link with stakeholders and bring them in to co-design the kind of ocean observation systems that we need so that we can bring the funding in to do the design work, because people still think you can have a workshop that people volunteer to attend and create a new design for ocean observation, as opposed to let's do 2 years of work at $10 million. So I think we need to up our ambition and join together to get this right. And I think we can, but it takes maybe, I guess in my experience, we're all still pulling a little too individually on our little carts to get ourselves funded, as opposed to working at a global scale to really lift it. So happy to have the conversation with anybody in this room anyway about how we can join together globally to really get that lift. Of course, Goose is ambitious to do that, but we're also shoestring funded, right? So, but we're hoping to change that. But again, hope is not a strategy, so we need to plot and work and get there together. So let's keep the conversation going.
Thank you. Thank you very much. Good point. Is there any other question? Please, Valentina, here at the front. Yeah.
Hello, thank you very much. I'm Valentina Sicardi from Barcelona Supercomputing Center, and I'm motion modeler, so I totally second what Martin said. Thank you. And my question for all of you is about the marine CDR. I would like to know your opinion because, of course, I guess it's strongly important for both SOLAS and the OASIS. So what do you think about it?
Yeah, I can speak a little bit to that. And Joanne mentioned MCDR earlier, and I think, and this ties back to Anya's comment about how we look for other sources of funding and thinking a little bit outside of the box. The private sector, I mean, there's so many startups jumping into this space for MCDR. And there's a lot of work also happening kind of in a similar vein on marine renewable energy development, for offshore wind and things like that. And I think how OASIS and SOLAS and our, science communities play a role in all of this is with respect to the monitoring, reporting, and verification, the MRV aspect of it. It comes down to regulatory compliance. And these companies need that. And they're going to be looking to our science communities to provide them with that data that they need. And ultimately, that's going to create value for them, for their business, strategies and initiatives over time. And so we need to be making that case, showing them how this is going to pad their pocketbooks down the line. They need to be working with us, funding us to make sure that we're, collecting the data that they're going to need in order to do all of these various different practices effectively.
Maybe I can add a comment. I can say something. As a Nick said, we need to collect data first, to support all those different kind of approaches proposed, like the artificial upwelling, like the alkalinity enhancement. So this kind of risk, right? There is always risk. If we do those kind of experiment as a coastal area, maybe the impact is smaller. If we do it globally, without enough scientific support, it could be a disaster. At least I think that. And so I think we need to do lots of experiments first, to see which way is practical. And how much it will cost, for each approach. We always care about money, right? And also, I want to raise another thing, from the science perspective. All those approaches, we need to work together with the company, right, to work it out. But, I work on the air-sea CO2 flux. The CO2 flux really is changing, in the past 20 years at least. And it's changing, I think it will changing, I don't know which direction it's going to, but the air-sea CO2 flux is definitely changing. How the CO2, the ocean uptake of the CO2 is changing. Right now, we still are not quite sure about it. The potential of the natural absorption of CO2, we need to figure out first. After that, if the CO2 uptake of the ocean is decreasing after the science research, if we get that kind of solution, conclusion, maybe we need to figure out the practical way, like the alkalinity, like the others. But I think for the natural process, I can give you one specific example. The global ocean is taking up CO2, but in the upwelling zone and in the equator Pacific is releasing CO2, right? And the general amount of CO2 uptake is like 2 petagram carbon per year, right? But in the equatorial Pacific, it can release like around 1.5, okay? That's a lot. So, but in the equatorial Pacific, the CO2 release, how is going to change? We are not sure. I think we need to do science first. Yes, that's my point of view. Yes.
Thank you. Is there any other quick comment? I would like to have just other questions after.
Well,
Sure, go ahead. Go ahead, Mike. Go ahead.
yeah, well, I'm not an expert on the on the CO2 removal by no means, but as a marine biology chemist, I have to say I'm super skeptical about the feasibility of this approach, because it appears to me much easier to cut emissions. So if we analyze the amount of energy we have to invest to remove this amount of emissions and how much it costs to not emit this amount of CO2, I think it's a much better alternative not to emit this amount of CO2. The problem is that, as we know, our socioeconomic system works in a way that, well, keeps pushing the emissions up, and I think we are focusing on the wrong solution, perhaps. But of course, this is creating a new economic sector probably, and there's perhaps a bubble, or there is not yet a bubble perhaps, but there might be a bubble of investment in this area, and I think it would be much better to invest in not emitting CO2. But well,
Yes, please.
Yeah, I think it's just that, I mean, the topic is here already, right? And I totally agree with you, but I think we cannot go back. People is already trying to do it. So I think we just need to be very careful on how we speak about it as scientists and say, this is not the option so we need to go to net zero or almost net zero before marine CDR can be an option to just address or limit the remaining carbon that we cannot. But I don't think we are speaking that way. And I think that's error on how, yeah.
I agree.
Okay.
I mean, I fully agree with what my colleague said. And I mean, all this is kind of reflected in the SOLAS position statement on climate intervention, which was released like 6 years ago. I mean, even for the new science plan, the solution-oriented science becomes a major pillar of the new science plan. But our position is still that it's our responsibility to provide solid data to investigate, to evaluate those techniques. But we're not in the right position to say this is the technique that we should adopt or disband.
Thank you. Thank you very much. It's a relevant question. Yeah. I think there's a couple of questions online.
We have a few questions online. The first one is, could you please elaborate on how regional research collaboration can be facilitated? Their organization, the National Oceanic and Maritime Institute, is interested in a research collaboration.
Would you like to elaborate?
Yeah, maybe I could say something about it, because SOLAS has a regional panel in Southeast Asia. I mean, I think it's case by case, depending on how the situation in that region is. But for the case of SOLAS Southeast Asia regional panel, I think they have their own funding strategy to support their work, because there are regional funding agencies available, and then that panel could collaborate together and then to apply funding to support their research. Yeah, that's their strategy, but there might be different strategies for other regions because of their region-specific situational conditions.
Thank you. Is there anybody else who would like to add something in the regional? Please go ahead, Mesha.
We have another one. I'm wondering what your views are on unifying across wealth boundaries, as it has been challenging to include developing countries, in particular from Africa, although they are among the most affected by climate change. What would it take to improve this?
Please. Yes, Martin.
Maybe I can comment briefly on that from my own experience with the DMS Pro working group, because, well, we have to admit we are working on a very specific topic, and so less than, well, a few research groups in the world working on this. But we struggled to find members from African countries, and in the end we were unable to integrate members from there, although we were aiming for like having a true global distribution. So,
if I may, can I contribute to this?
of course.
No, just because as on the early career committee from SOLAS, we had exactly the same issue, and only South African researchers come because they have a structure that is more similar to the European than in other African countries. What we realize now with the call, we have a current call actually for early career researchers, so please, if you want to join us. We are getting really good candidates who are not very expert maybe on the SOLAS science, but who are ECOPs and who are playing a relevant role on marine science and marine infrastructures in their countries. So I think that we should be, not for the case of the working group, for instance, that's different, but for a case of our networks, we should be more open to embrace SOLAS science, fisheries, maybe topics that are not air-sea exchange, but because I think it's more important to have these voices at the table than to have a very good expert on a super particular topic. So that would be my point on this. Sorry about that.
I mean, I would agree with that strategy. I mean, actually, that's the case for SOLAS Summer School as well. I think to answer that question, capacity building is always the key. And SOLAS has been organizing activities in Africa, like our past summer school in Cape Verde, and then the last Open Science Conference in Cape Town. I mean, for the summer school in Cape Verde, when we received applications, there are examples like what you said. It's not totally from the SOLAS domain, but yeah, but it's a way to enhance their research capability. And then another way is that SOLAS is also part of the new science plan, and we have been discussing that we should organize the shared data observation and modeling expertise. That's another way to go, and we had a very good example that the research, the Oceanography Research Institute in Cape Verde, which hosted our last summer school, actually is a joint effort between UMA and then Cape Verde, and then it's promoted by SOLAS scientists. I think that's another way to go.
And I'll just, sorry.
Yeah, also from the OASIS perspective, I think we are actively looking for funding, for example, to support early career ocean professionals. And also there is a task group working with small island communities and Global South. So I think there are opportunities that we can look for.
Please,
also within OASIS.
Thank you, Lucy.
Yeah, and I was just going to quickly add to this. So there's an event on Friday, just making a plug for one of my colleagues, Juliet Hermes from South Africa, is organizing a session on ocean observing in Africa, and it's being attended by the president of Cape Verde. So I would encourage folks to go there to learn more about that, but also just make a note that we're actively discussing that. And I think I see a hand in the back left, and that might be Brian Arbeck, who's the expert in this, on this topic. Yeah, this is the guy. You want to ask?
Hi, I am Brian Arbeck from Michigan, and I'm a physical oceanographer who works on big supercomputer type models, including air-sea interactions, but I also have been running a summer school in West Africa every year for 10 years. So I think I'd be interested to hear more about SOLAS. It sounds like your summer schools kind of hop around, but a separate approach is we go every year to the same place. And my feeling is that if you go to the same place every year for 10 years, you build long-term trust and collaborations that enable large proposals. So we have about $35 million in pending proposals right now from foundations and governments, and they're not on air-sea interaction, but they're on biogeochemistry and related topics. But you know, we have a global endorsed program from the decade to do more of this. And so I guess what I would suggest is I think capacity development is a key aspect of the decade. And I would advocate, you know, having sustained summer schools in the same place year after year. And, you know, you could have in this place do air-sea interaction, in this place do carbon cycle, whatever. And I think that sort of thing could lead to, more Africans being involved in this, in all the decade programs, this one and all the other big ones.
Can I quickly answer that?
Yeah, please.
Yeah, thank you for the comments. Actually, among the past 9 solar summer schools, 7 of them were organized in France, Corsica island. But I mean, that's nothing related to capacity building in developing countries. But we do have some ideas on organizing regional summer schools, which could be a regular happening event in that region or country. Yeah, that's probably next what we're going to do.
Yeah, I guess I'll also mention I'm co-chair of the working group on capacity development, so we'll be presenting our white paper on Friday. So I think about this stuff a lot, and I'd love to talk to more of you. I'm very impressed that SOLAS has run 9 summer schools. That's great. I'm a big fan of that kind of thing. Because one thing I felt like summer schools, scientists are really busy. And so expecting scientists to spend a year, abroad, that's pretty difficult. But if you have a summer school every year, it's not that hard to get people to come for a 1-week summer school. And you can get people engaged for the long term.
I totally agree,
Yeah.
Thank you. We are a bit short on time, so please, Marty, Masha, do you still have questions online?
We have one more,
Okay, so
and we can make it quick. A broad question for the panel, building a bit on what Nick said. I think advocating for both scientific funding and scientific equity are extremely important, but it's not clear exactly how to be heard and who should hear. It seems like a unified strategy at a high level would be useful for this. Do the panelists have any tips or suggestions on ways to actively advocate effectively, and where do we start?
Wow, that's a good one to finish.
It's a good one, but
Well, plug for another session too. On Friday, there's a matchmaking session on connecting the Ocean Decade programs with funders. So I will be attending that and trying to learn more exactly on how we, who is out there and be thinking about who we in our ARC community should be connecting with for funding. But I think as far as how we unify it, I think we have to approach it like you would any kind of political campaign, where we need to have an actual strategy of how we're going to attack and go door to door, knocking on government offices, talking to CEOs, talking to philanthropists, and it needs to be on a region by region basis, because funding frameworks are approached so differently from nation to nation. And so, but if you look across the representation on our groups at SOLAS and OASIS, we have that representation. We just need to come up with an effective strategy and get our people to get out there in front of those who have the checkbooks.
Thank you.
Matt?
Yes, please.
Yeah, I mean, maybe I can share with you what SOLAS did at the very beginning. So when SOLAS firstly launched, so we tried to organize our annual SSC meeting at different countries and then invite national funding agencies to join the meeting and then show how important the topic is. And then, yeah, you should put money in this research. Yeah, that's kind of a unified fundraising strategy when SOLAS firstly launched. But I mean, we don't do it now, but I mean, yeah, why not? We can still do it.
Thank you very much. I'm afraid we should try to wrap up. There has been lots of good ideas, and we'll actually, so this being recorded will be in YouTube, and we'll create a report of this event. So it will be a way of remembering all what has been discussed. Maybe just the ideas I've noted. I don't know if you will agree with me, but that I found that were really interesting. One I really loved is that it seems that we have a strategy, and what is hard is how we implement it. And I think that's a change in the question we actually put ourselves at the beginning. So we know what we need to do, but how we do it, and we should maybe focus more on this how, and with which partners we engage, and how we bring money, and how we support the networks. And that connects to the ECRs comments that networks are particularly important for ECRs, for looking for important questions, as Shualing was saying, but also for swimming in this, like this. I totally agree with you. As multidisciplinary researcher, you always feel that you don't know enough of what you're working, but at the same time, funders ask for this multidisciplinary. So I think that networks need to support early career in this sense, not only in the funding, but also on giving advice and showing that their research is important. I also really like some more scientific aspect that Shualing highlighted about the climate change impact on the RC flag. So and that connects to the MCDRs. Now we're proposing to use the ocean, but we don't know how the system is already changing. So we don't even have a historical background line to use as reference. So that makes things much more trickier. And we need to dramatically improve the ocean biochemical models. I totally agree with this. And maybe something that should come up from this event is to propose how these, or which of these elements need to be included in models. And also, and that's a crazy idea I just got, but maybe why not putting together a recommendation on MCDRs, on the need of fundamental research in order to support MCDRs. Of course, I agree that we cannot say no to MCDRs, they're there, but it needs to be clear which is the position of the science, and your point is critical. It's like without net zero, MCDRs are completely useless, and this is not being communicated at all. And the numbers show it. That's very easy to show it, actually. So maybe that could be something to work together on. I don't know if you'd like to include or add anything else that I'm sure I forgot. Otherwise, thank you very much. Thank you, the audience, for coming. Thank you, the online audience. I think that was a great panel. I really enjoyed it, at least myself. So thank you all. Thank you particularly to Cassie and Max. That you were there. Yeah.